In the next problem, we'll cover collecting gases over water. Remember that when you collect a gas over water, you have to account for the partial pressure of the water. And the partial pressure of the water is determined by the temperature. So you need to use a chart like this, which gives you the vapor pressure of water at specific temperatures. For example, the vapor pressure of water at 30 degrees C is 31.86 millimeters of mercury, and the vapor pressure of water at 50 degrees C is 92.6 millimeters of mercury. So, according to Dalton's law, if you have a mixture of gases, the total pressure of the gases is due to the partial pressure of each of the gas components. So if one of those components is water, then the total pressure is going to be due to the partial pressure of each of the components of the mixture plus the partial pressure of water. Now, if you collect a gas over water, you have to account for the partial pressure of water at that temperature because there will always be water mixed in. So let's read the problem. In order to determine the rate of photosynthesis, the conversion by plants of carbon dioxide and water into glucose and oxygen, the oxygen emitted by an aquatic plant is collected over water at a temperature of 293 Kelvin and a total pressure of 755.2 millimeters of mercury. Over a specific time period, a total of 1.02 liters of gas is collected. What mass of oxygen gas in grams forms? So what we're told is that we have this kind of aquarium set up where there are plants growing in the aquarium. The aquarium is initially filled completely with water, but over time, from photosynthesis, from the sunlight and the carbon dioxide, the plants will emit oxygen gas in the form of O2, and that oxygen collects in the top of the container. But in addition to the oxygen gas, you'll also have water vapor mixed in with the oxygen gas, and you have to account for the water vapor as a partial pressure. So what we're given is the temperature and the total pressure and the volume of gas that was collected. We're asked to find the mass of oxygen that forms. So, from the partial pressure of oxygen, the volume that was given, and the temperature that was given, we can calculate the number of moles of oxygen. And from the moles of oxygen, we can calculate the grams of oxygen. But in order to calculate the partial pressure of oxygen, we need the total pressure, which was given, and then we have to subtract the partial pressure of the water vapor at that temperature. Right? And so the partial pressure of oxygen is going to be equal to the total pressure minus the partial pressure due to the water vapor. Okay? So then when we have the partial pressure of oxygen, we can calculate the moles of oxygen, and then from the moles of oxygen, we can calculate the grams of oxygen. So the partial pressure of oxygen is equal to the total pressure, which was given, minus the partial pressure of water at that temperature, which was 20 degrees C. Okay? And so that's 755 millimeters of mercury. So that gives us a partial pressure of oxygen of 737.65 millimeters of mercury. From that partial pressure of oxygen, we can calculate the moles of oxygen. Okay, by putting the partial pressure in to the PV equals nRT equation. So the moles of oxygen is equal to the partial pressure of oxygen times the total volume divided by R times the temperature. All right, and so we need to convert our pressure of oxygen to atmospheres here. Okay, and so now we have 0.97059 atmospheres. Okay, and that is from the partial pressure of oxygen here. So we convert that to atmospheres, we plug it into our PV equals nRT equation, and so we have the P the V, the R, and the T, which gives us the moles of oxygen. Now we can convert moles to grams from the molecular weight of oxygen. Oxygen is diatomic, and that means from the periodic table, oxygen weighs 16 grams per mole, but we have two of them in the diatomic molecule, so it has a molecular weight of 32 grams per mole. So our mass of oxygen that we collected was 1.32 grams. Next we'll work for practice 6.11. A common way to make hydrogen gas in the laboratory is to place a metal such as zinc in hydrochloric acid. The hydrochloric acid reacts with the metal to produce hydrogen gas, which is then collected over water. Suppose a student carries out this reaction and collects a total of 154.4 milliliters of gas at a pressure of 742 millimeters of mercury and a temperature of 25 degrees C. What mass of hydrogen gas does the student collect? So similarly to what we did before, we have a system where we have gas collected at the top from a reaction that's occurring inside a closed flask. And it's originally completely full of water, but then as the reaction occurs, the gas is collected. Okay? So remember that our total pressure is going to be equal to the partial pressure of the components. And one of those components is going to be water. So in this case, the total pressure is going to be equal to the pressure of the hydrogen gas plus the pressure of the water. So to find the pressure of the hydrogen gas, we need to subtract the partial pressure of the water from the total pressure. If you look up the pressure of the partial pressure of water at 25 degrees C, it's approximately 24 torr. Okay, and so we can calculate the partial pressure of hydrogen from 742 torr, which was given, which is the same thing as millimeters of mercury, minus 24 torr due to the partial pressure of water, which is 718 torr. Okay, and so our partial pressure in atmospheres is equal to 718 torr, and we convert it to atmospheres. 760 is 1 atmosphere. And that's equal to 0.94477 atmospheres. Our volume was given in milliliters, so we need to convert that to liters. 154.4 milliliters. 1 liter is 1,000 milliliters, and that's equal to 0.1544 liters. Now, we can use the PV equals nRT equation, where N is equal to PV over RT, so that's equal to 0.944737 atmospheres times 0.1544 liters divided by R, which is 0.08206. And let's go ahead and put the units in. Liters, atmospheres per mole Kelvin times 298 Kelvin, which is equal to 0.005964999 moles. Okay, so now we can convert the moles to mass because we were asked to find the mass. So 0.005964999 moles of H2, right? And we have 2.016 grams of H2 is 1 mole of H2. Now, how did I get that? H2 is a diatomic molecule, and hydrogen weighs 1.008 grams per mole. I have 2 of them, so that's 2.016. Now I know that 1,000 milligrams of anything is equal to 1 gram. And so that gives me 12.0 milligrams of H2.